the rules. So the first one is the integral x to the n dx is the integral, becomes x to the n plus 1 over n plus 1 plus c. The integral of just a number, k dx, k is a number, equals kx plus c. Basically, you put that k in front of x because of that letter there. We also learned that the integral of 1 over x dx, which is really the same as the integral of x to the minus 1 dx, equals the natural log of the absolute value of x plus c.
Okay.
I think that summarizes everything that we've done. And then I started introducing some examples with exponents, and the exponents were integers, some were decimals, fractions, and so on. So if you don't have this down, you will. I'll probably send you an integral table today to have as part of this lesson. Okay, so ready for your first example?
Yes.
Okay, me too. I need to scroll the screen down. There it is. Okay, so let's say we want the integral of 4 plus x over x squared dx. There's a rewrite step. And the rewrite step is 4 over x squared plus x over x squared dx. And then as part of that rewrite step, we're going to simplify / rewrite, like we're going to manipulate what's inside here. So it's the integral 4x to the minus 2 plus 1 over x dx. So what's really important here, I guess I didn't quite get all of this in one screen, is you really want to be able to go from this first line, you want to be able to go from here to here in one step.
Okay.
So the more you can do that, the faster this will go, the easier the class will be, and so on. So for this one here, it's 4x to the minus 1 over minus 1 plus the natural log of the absolute value of x plus c. Okay, because you add 1 to the exponent, you have the same exponent top and bottom. This natural log of x comes from 1 over x, like that. And then you would simplify. You'd say negative 4x to the minus 1 plus natural log absolute value of x plus c.
Okay.
Okay, so you ready to try one on your own here, like this?
Wait, can I take a look at it?
Of course.
Okay. I have to do it in one step?
I'll give you one just like this, with just slightly different numbers.
Yeah.
Okay, so let's go 5x plus x cubed over x to the 4th dx.
I have to do it in one step? Or...
No. You can do it as many steps as you want, but I'm asking you to do this one on your own.
Okay.
As review.
Okay.
All right, do you have your final answer, or do you need me to step through this?
Can you step through it?
Sure. So this is what I meant by, like, I'd really like you to be able to do this in one step. Were you able to get to there?
I got 5x to the power of 3, not -3.
But there's one up top and there's 4 on the bottom. Right? So those cancel and there's a 1 left over. So it's 1 over x cubed, which is x to the -3.
Okay.
Okay, did you get 1 over x?
I got,
Because x cubed
yes.
over x to the 4th, it'll just diagram this x times x times x over x times x times x times x. So, you know, a bunch of things cancel and you get 1 over x.
Okay.
Okay, so now did you find the integral of each of these? Did you use the power rule for this one on the left?
Power rule, no.
Okay, so you gotta add 1 to the exponent, right?
Yeah.
Then you divide by the new exponent. Plus natural log absolute value of x plus c.
Okay.
Okay, and then you got to simplify. So it's -5/2 x to the -2 plus natural log absolute value of x plus c.
Okay.
All right, let's try another one here. So you're at the point where you got to be able to do these for us to move on to new stuff. So because they just get a little bit harder from here. So let's have you do the integral of x squared minus 4x over x cubed dx. You want to give that one a try?
Okay.
I'm going to step away for 30 seconds. Be right back. All right, I'm going to write out a few steps here.
Yeah.
Is this what you got for your simplified version?
I got natural log of x.
Natural log absolute of x, yep.
Yeah, minus 4x over -1.
Plus c.
Yes.
Okay, and then this simplifies, so natural log absolute value of x plus 4.
Wait, over -1. Oh yeah.
Yes.
Yeah.
4x to the -1 plus c.
Okay.
All right, so let me introduce a couple of new integrals, and then we'll keep working on this other stuff, just in part. So there's some table of integrals that you need to know. So the integral of cosine x dx equals sine x plus c. Okay, do you remember what the derivative of sine is?
It's cosine.
It's cosine. So the integral of cosine gets you back to sine.
Not in negative sign.
No. So the integral of sine x dx is minus cosine x plus c.
Also, there's a difference between the derivative of a cosine and the integral of a cosine.
Well, of course. So if we come over here, and if we start with sine x, what is the derivative of sine x? It's cosine x, right?
Yeah.
But the integral goes back this way. So the integral of cosine gets you back there.
Yeah.
The second derivative of cosine x, or I'm sorry, the derivative of cosine x is minus sine x. Okay. The derivative of minus sine x is minus cosine x. Okay. So like if you want to go backwards, which you can, I mean, that's the rule, but most people just remember these two right here.
Okay.
The integral of sine is minus cosine. The integral of cosine is sine.
But up, like the first one, it says cosine is sine only.
The integral of cosine becomes sine plus c. These are just definitions. These are just like, we're going to use these.
Okay.
The derivative of minus cosine gets you back to sine.
Okay. Okay.
Okay, so another one that you need to know is the integral of e to the x dx equals itself, e to the x plus c. Okay, now there's a bunch more, but these are kind of the standard ones that you need to know. So the three I showed you earlier, plus these three we're going to work with for a while until you feel comfortable moving past them.
Yeah.
Okay, so we'll just do a couple examples here. So what is the integral of 2 sine x minus 3 cosine x dx? Okay, so in addition to the integrals, there are properties. Okay, so one of the properties says that you can break this apart. It's integral 2 sine x dx minus integral 3 cosine x dx. Have we talked about that? Or have we seen that before?
Yes. Yes.
Okay, great. So we just talked about on the right here, the integral of sine x is minus cosine x plus c. You remember that from above? Right up here. Or the second one. Integral of sine x is minus cosine x.
Okay.
So this right here, like this, the sine x becomes minus cosine x.
And the two.
And the 2 comes down.
Oh.
So, but you really want to put it here. So it becomes minus 2 cosine x.
Okay.
The integral of cosine x is sine x plus c. So this part right here is sine x. You bring the 3 down and you have a negative there. Is that okay? Like, do you follow that?
Yes.
The integral of cosine x is sine x. The integral
Okay.
of sine x is minus cosine x.
Okay.
Okay, so then this is what's left over, minus 2 cosine x minus 3 sine x plus c.
Okay.
Does that follow? Does that work?
Yes.
All right, so let's try another one here. What is the integral of 5 sine x minus 3 cosine x dx?
Can it be -5 cos x?
Negative 5 cosine x.
Plus plus 3 sine x.
So it's actually minus, because this right here becomes sine x plus c.
Under sine x, not a negative.
No, I mean the integral of sine x, like you said, is minus cosine x. The integral of cosine x equals sine x.
Cosine to sine. And x to okay.
Okay, so this is correct here.
Okay. Yes.
All right, so let's just do a quick review here. Let's say I wanted the integral of 4 cosine x minus x plus 1 over x dx. Can you try this one on your own, please?
Yes.
I'll be right back, Mud.
Okay.
All right, Hamad, how's that going?
I got to 4 sine x minus x squared over 2.
Okay.
Plus plus 1 over 1 over natural log of
So value of x plus c. Good. Okay, let's try another one here.
we have to simplify the negative x squared over 2.
It's okay like this. You can write 1/2 if you want.
Wait, how to simplify this? I forgot how to.
It is simplified. You would it's just a rewrite. It's just a,
Oh,
if you really want, it's not any different. You could write this.
okay.
Okay. The let's do another example. Let's go integral minus 6 sine x plus 5x minus 3 over x squared dx.
Wait, so the negative 6, it's so it's like negative sign or no?
It can be. I mean, you could look at this as sine or negative sign. Either way is okay. But it's just the number in front. Like truly, this right here is -6 integral sine x dx.
Okay.
If you want, like this is what I care about, that you know how to do.
Yeah. So it's gonna be negative cosine. It's gonna be positive. So 6 cos
6 cosine x. Yep.
6 cosine x plus 5x negative 3. Oh, this is the power 2 or what? Or negative 3? Is it?
This is what I get when it simplifies. 5 over x minus 3x to the minus 2.
Oh, so it's not 5x to the power of negative 3.
Nope, you got to divide both of these.
Oh, so the
Oh,
negative
oh,
3 has, I
the
thought.
-3 is kind of off to the side.
Oh, okay. Wait, how did you do this? It's next.
You divide both of these, so you divide 5x over x squared minus 3 over x squared. So this one becomes 5 over x. This one becomes minus 3x to the minus 2.
Wait, how does it become 5 over x?
And one of the x's on top cancels one of the x's on the bottom. 5x over x times x. These cancel.
Okay.
Okay, so what is the integral of these two over here on the right? 5 over x minus 3x to the minus 2.
Wait, could we go up a little bit? I want to see.
Sure.
Wait. Okay. Got this. Okay, so the derivative of 5 over x is natural log of the absolute value of x.
Yes.
So you have to put the 5 also?
Yes.
Oh, um, it's gonna be negative 3x to the power of negative 1 plus e.
I need a few minute break here, Hamad. I got to deal with a technical issue.
Okay,
Be right back.
okay.
That's it.
Hi, Hamad, I'm back.
Oh,
We're gonna just extend the lesson time. So let's do another example here, if you're ready for it.
Yeah.
Let's go 5e to the x plus cosine x minus 2. Let's go x to the minus 1 dx.
okay. So it's gonna be 5ex
Okay,
plus sine x
how about this next one here? What does it become?
plus sine x or negative sine x?
It's sorry, plus sign.
Minus 2x.
X to the minus 1, what does it become? It's one of the ones I gave you. Natural log absolute value of x plus c. This right here becomes this.
Okay.
All right, so let's do a couple more here. Let's say it's the integral square root of u minus sine u plus 3u squared over u cubed du.
Yeah. So this is gonna be u squared.
Which one? This one here?
Yes.
It's u to the 1/2 power. Integral. You're just rewriting it.
Okay. Then minus sine
So let's go to one of the first sources.
plus. So don't change the negative sign to the.
We're not taking the integral yet. We're just rewriting this. Rewrite means not taking a math step of like calculus. We're just changing the way it looks.
Now it's gonna be 3u power of 3.
What is this simplified to though? U squared over u cubed.
Oh, okay. It's gonna be natural log of absolute value of x plus
It is after when you take the integral. You're still not taking the integral.
3 over u.
Yes. So just to be clear, there's no calculus yet. This is all previous knowledge.
Okay.
Now you can use your calculus at this step. So what is u to the 1/2 power? How do we integrate that? Which rule do we use?
Use the rule half plus 1 over
Right. 1/2 plus 1.
2 over 2, which is 3 over 2.
Okay. 3 over 2.
U to the power of 3 over 2 over 3 over 2.
Okay.
Plus cos.
Okay.
Plus natural log of the absolute value of x plus c.
It's u because we're using u. But what about this 3? Where does it go?
That goes beside the ln.
Yes. Okay, so how do you simplify this over here on the left? And keep in mind there's a 1 there, 1 out in front.
So you do 1 times 2 over 3.
Yes. So it's just 2/3.
Yeah.
So 2/3 u to the 3/2, and then all of this comes down with it. Okay, good. Let's do another one. Integral 5 over square root of y minus y squared plus 3y over y squared. plus e to the y dy.
So that's gonna be um 5 over y to the halves plus
So do you know how to rewrite this from yesterday? We did an example like this.
if I'm doing it. Yes, I got.
Okay, so this is not a calculus step. This is just a rewrite step.
Oh,
So from here, can you do the calculus? Can you use the rules that we've talked about?
yes. Plus 1. From where did you get the? Oh, the cancels out.
Yep. Then you have 3y over y squared.
Wait, how did you get the y2?
So y squared over y squared plus 3y over y squared. So this up here,
How did you get the 1?
well, this first one you have y times y over y times y, and they all cancel, but 1 is still remaining on the top and the bottom. Because you can always multiply by 1.
Okay. Okay, plus 1.
Okay, so now are you ready to do the calculus here for this line?
It's gonna be. Yeah. Gonna be 1/2.
Okay, so it's 5y to the 1/2 over 1/2. But what about the rest of it? We got a lot more here to do.
Plus 0.
Nope, that's the derivative. The derivative of 1 is 0, but we're going the other way. So what do you take the derivative of to get 1?
1. It's gonna be 1/2. 1 to the power of 2.
Nope, go back to, I'm scrolling up here.
Oh, yeah. 1 dx.
Well, it becomes, so it's all the way in the beginning here. It just becomes whatever that number is times x.
Okay.
So if it's 4, it's 4x. If it's 5, it's 5x. If it's 1, it's just
1y.
1y.
Okay. Plus 1y plus. That's gonna be the natural log of the 3 to the natural log of the absolute value of y plus e to the y.
Yep, plus c. Okay, so how does this first one simplify?
It's gonna be 5 times. Oh, it's gonna be 10y half. Okay.
Okay, so we haven't done much trigonometry. And there's a couple of things here that you need to know before we move forward. Okay, so you know about sine x, you know about cosine x. Tangent x is sine x over cosine x. You recall that?
Okay.
Okay. Now, cosecant x is 1 over sine x. Do you see how it's the flip of that?
Yes.
So what would be 1 over cosecant x? Well, it's 1 over sine x. And what does that become? You just did one like this. It's like 1 over 1/2. What does that become? Just the sine x. Right. So the analogy is like, what is 1 over 3? Well, it's 1 times 3 over 1, which equals 3. So it's just this number.
Yes.
It's just this. So I bring that up because the instructors will kind of hide what it actually is. So the next trig function you need to know is secant x. Secant x is 1 over cosine x. So then what is 1 over secant x? What is the reciprocal of this? Well, it's 1 over cosine x, which is just cosine x.
Where?
It's for the same reason as this top one. Have you seen these before? Sine, cosine, tangent, cosecant, secant?
Wait, I think. Where? Which one?
1, 2, 3, 4, and 5. Have you seen those before?
Yes.
Okay. So like nothing I'm showing you is new. I'm just showing you some relationships between them that might come up.
Okay.
Okay. And then cotangent x is 1 over tangent x, which is the reciprocal of this. It's 1 over sine x over cosine x. Do you see how sine x over cosine x is tangent x? And then you flip these, so you get cosine x over sine x.
It's just cosine?
No, it's cosine over sine.
Okay.
Let me grab a cheat sheet here and see if this helps. All right, so what I'm trying to summarize is the information here, but I'm also going a bit further. So I'm trying to get you to remember these things because they do come up in this class. Like I'm asking you to like, do you know these things? And then I'm adding on like 1 over cosecant theta is sine theta. 1 over secant theta is cosine theta. Okay, and you might be thinking, well, why do I care, Matthew? Well, here's why. I'm going to ask you, what is the integral of sine x minus cosine x plus 1 over secant x? Actually, let me back this up. I could ask you the integral of 1 over secant x plus 1 over cosecant x dx. It's totally reasonable for me to ask you this because this first one, secant x, is really 1 over cosine x. This is your trig. So that's this rewrite step is 1 over cosine x. And what does that simplify to?
I don't get what's happening. It's too much.
Okay, well, this is all stuff you're supposed to know before you take this class. So we should spend some more time looking at this.
Okay.
If that's what's needed. Do you want to do that, or do you just want to go back and do more of the integrals like we were doing earlier?
Which one's more important? Because
I mean, you got to learn your trig at some point. It's a big part of this class. But it's up to you. Up to you.
Like I won't get that the first day of class, or
Maybe the third.
Oh. Okay, we'll like how can this be a question?
Okay, let me try to tell you where we're going so you can get some idea. First day of Calc 2, they're going to review integral rules. Second day, they're going to talk about what are called U substitution rules. Third day, they're going to talk about integration by parts. Fourth day, they're going to go to partial fractions. Fifth day, they're going to cover trig substitutions. Now they could switch the order here, okay? And then they've got table lookup integrals. Everything we have done for the past like 4 or 5 lessons is all right here. This is your day 1 stuff.
Okay.
So we are like, my plan was to move to use substitution soon, but I was trying to introduce some other stuff here to see how comfortable you were with it, just to kind of gauge it.
I'm kind of lost when you
Right.
Yeah.
Right. So like, but you know, it's coming. Like you need to learn your trig by here. Like this is day 5. I mean, it's week 2 of your class.
Yeah.
So what do you want us to do? Do you want us to continue doing the integrals we've been reviewing? Do you want us to look at some trig stuff now?
So you think I'm good with the integrals or?
No. I mean, we're like, you got to be able to do them fast too. So we got to, you know, we could move on, but so here's okay. Let me try to do a better job here. This is your first WebAssign question that you'll see maybe is integral 7u minus u squared over u cubed du. And you need to be able to do this in about 1 minute.
Oh, 1 minute.
Yeah.
I'll 7 u over u. So that's going to be a natural log of x minus. No, that's going to be. No, that's going to be 7 over. No, that's going to be a half 7. So, no, that's going to be.
So this is how fast that you have to be when you get to the class. So
Wait,
that,
how?
well, 7u over u cubed. You have u times u times u. So those cancel and you get 7 over u squared, which is 7u to the minus 2. Okay. And then u squared over u cubed is 1 over u, because you got 2 u's up top and 3 on the bottom. And then you integrate it. Yes. And that's, but this is like, again, like this is number 1. Okay. And then I added this is called definite integrals, something else we can kind of talk about. We can talk about it any time though. So let's keep going here. Let's do some more here.
Okay.
Okay. So let's do integral 16x to the 2/3 minus 12 x to the minus 3/2 plus 4 sine x minus 3 e to the x dx.
Yeah, so 16 x to the 2 over 3 plus 3 over 3, which is 5 over 3 over
Mhm.
5 over 3 minus 12 x to the power of -1 half. -1 half plus 4 negative cos. So it will be -4 cos x. Then you keep it. It will be 3 x plus c. Okay.
Yes. And then you can simplify if you want. Okay, so let me give you just a brief trig review here. We got another 10 minutes here. Because I shorted you some time. So most of trig is based on right triangles.
Okay.
A, B, and C. This is A, this is big B, this is C.
Yeah.
So sine big A is A over C, little a over little c. Okay, cosine big A is the adjacent over the hypotenuse. It's B over C. And you do need this in calc too, like this is going to come up. So then tangent of A is A over B, opposite over adjacent. Now I mentioned to these before, I said cosecant of A is 1 over sine A. So it's the reciprocal of sine A, like whatever sine A is, it's the flip of it. So it's the flip of this number here. So it's C over A. Do you remember this from a previous class or maybe high school?
No.
Secant of A is 1 over cosine A. It's the flip of this. C over B. Cotangent A is 1 over tangent of A. So it's the flip of this. So it's B over A.
No, I don't get this.
You've never seen this before.
No.
Okay. Well, that's not good. Let's see here. So an example of this is I give you a triangle. I tell you that this is 3, this is 4, and this is 5. And this is A. And I ask you the sine of A. The sine of A is the opposite side,
Okay.
3 over the hypotenuse 5.
Okay.
The cosine of A is the adjacent side over the hypotenuse.
Okay.
The tangent of A is the opposite over the adjacent, so it's 3 over 4. The cosecant of A is 1 over sine A. It's the reciprocal of sine A. So it's really 1 over 3/5. It's 1 over this number, but you know to flip this on the bottom, 5/3. 1
Okay.
over 3/5, right? 1 over 3/5 equals 1 times 5/3. That's why it becomes 5/3. Secant A is 1 over cosine A. What is cosine A? 4/5, which is 5/4 because you flip it. You flip this right here. And then cotangent A is the reciprocal of,
Like they will give me a triangle like this.
not in this class, but like, remember what I was showing up here, these trig substitutions? It
Yeah.
will refer to triangles when you're doing this, when you're doing these. It'll tell you that this is 9 and this is x and this is the square root of 9 minus x squared. And you'll use this in an integral.
Okay.
Okay, so 1 over tangent A is 1 over 3/4, which is 4/3. Let me try something else here, see if you remember these. Do you remember any of these Pythagorean identities that I'm showing you here? The first one is usually the most common. This one right here. Have you seen that before?
No.
Okay. So let's look at a triangle. Let's look at the same one. We just did 3, 4, and 5. And let's say that's theta. Theta just means the angle. So from our previous problem, what is sine theta? Do you remember?
It's gonna be 5 to the hypotenuse. No, that's
3/5, right? And then cosine theta is 4/5.
wait.
It's adjacent over hypotenuse.
Okay.
So if we use this identity,
The sign is the what's it called? The 3, the side of the 3.
well, so it depends where you are. So this is opposite,
Yeah, opposite. Okay.
and this is adjacent. But if you were up here, let's say you're this angle, then 3 is the adjacent and 4 is the opposite.
Okay.
Okay, so like we can use this. So is 3/5 squared plus 4/5 squared equal to 1? See how I just took these numbers, put them in?
Yes.
Okay, so you square the top, 9 over 25 plus 16 over 25. Does that equal 1? Is 25 over 25 equal to 1? Yes.
Yes. Okay.
So you have not seen these identities before.
No.
Okay, so they do come up in that unit that I mentioned with trig substitutions.
Okay.
All right. What else here? So here, let me grab this. I hope the answer is yes to this. Have you seen the unit circle before?
No.
You've never seen this before.
Unit circle. Like this exact picture?
Something like this. Or I mean, I can give you the full picture, but this is the first quadrant.
I've seen the 90 degrees, 60, 45, 30, 0, and the 360.
So if I asked you for like the sine of 30 degrees, do you know what to do?
No.
Okay. Yeah. Okay. So there's a lot there. It sounds like you've never taken a trigonometry class.
No.
Okay. And that is a prerequisite for calculus. And then for Calc 2, it's needed, but you can probably learn it along the way. So the way the unit circle works is it's a circle with radius 1. And as you mentioned, there's these like known points along the unit circle.
Yeah.
Okay. So the x value is cosine and the y value is sine. So if I ask you for the cosine of 30 degrees, what I'm really asking for is the x value there. See how there's an ordered pair here, x and y.
Yes.
It's the square root of 3 over 2. The sine of 30 degrees is the y value here. What's the y value there? 1/2. So what is like the cosine of 45 degrees? Well, you go to your unit circle, there's 45 degrees.
Is the square root of 2 over 2.
Right. And then sine 45 degrees is the same, square root of 2 over 2. Okay. Now, generally, though, these are going to be given in what's called radian measure in your class. Okay, so it'll be more like this. It'll be, what is the cosine of pi over 3? And you're supposed to say, oh, it's right there. It's the x value. It's 1/2. What is the sine of pi over 3?
Wait, is it all given or no?
No, you have to know this. You'll be expected to memorize this.
Like how? Like how memorize where? Which one?
The whole thing. So the whole thing is, let's see if I can get it here. Let's get a snip of this. Grab it here. I've almost got it snipped. So all four quadrants, and you'll need to know, there's actually some rules you can use to make this simpler, but you for sure have to know the first quadrant and then be able to figure out the others from it. And this all comes from your trig class. Okay, do you want to schedule a time for tomorrow or Thursday?
For tomorrow?
Yes. You got one more lesson we got to use up. So do you want to do it tomorrow or Thursday?
I'll text you and see my schedule.
I really need you to, I really need a decision. Like, do you have a preference for one day or the other?
Tomorrow.
Okay. What time does 1 o'clock work for you?
I think I have a class at 1.
Okay. Is it something you can look at right now, or do you need
Yeah,
to?
I can look at right now.
Okay.
It's